Hi everybody, welcome to another video in Calculus 1, section 3.8, implicit differentiation. So, differentiation meaning taking derivative. So, before we actually go to implicit differentiation, there are two ways to write a relation between y and x. We can write y as a function of x. In this case, we call that the explicitly define y as a function of x. Whereas we write f of xy equal to 0, this is an implicit form. So, I give you a simple example here. The explicit is y is equal to x squared. So y is a function of x. So that is explicit. Implicit, I can write the same thing, but move everything on one side, like y minus x squared equal to 0. So when we have the equation, that is called the implicit equation, and explicit is a function, meaning that for every x there's only one y. Of course, we'll talk about that in a minute. Sometimes it is difficult, if not impossible, to solve for it. For example, in this equation, we won't be able to solve for y in terms of x. Nobody can. So in that case, we just have to leave it like that. The goal here is to find expression for the derivative for the equation without solving for y. So we don't need to solve for y. But the derivative itself may have y in it. This technique is called implicit differentiation. So once again, I want to distinguish two things. The explicit function and the implicit equation. So when we have something like this, x squared plus y squared equal to 1, this is implicit because it is not a function. A function have to pass the vertical line test. So if I draw the vertical line and it cut the graph at more than 1 point, then this is not the graph of the function. So if I draw the vertical line here, it cut the graph at 2 points, so it is not a function. Right. If I want to write the function equivalent to this, which I cannot, I can have to write two explicit functions for it. One of them is y equal to square root of 1 minus x squared. In that case, this is the top. That is y equal to positive square root of 1 minus x squared. And then if I want the other half, I will have this one, the bottom half. So in that case, yes, those two implicit functions together combined give us the implicit relation. So if we only have a half, draw a vertical line, it will cut the graph at 1 point, so it passes the vertical line test. Therefore, those two are functions. And this is not a function. This is just an equation. Right. In terms of derivative, how do we take derivative implicitly? Implicitly meaning we do not, or we don't have to solve for y in terms of x. So let's go back to the chain rule. Let's say I want to have derivative of the function, like very simple, like this, and I want to take derivative. In that case, I can say y is equal to u to the fifth, where u is equal to x plus 1, right? And then derivative of that is going to be 5u to the 4th power. And then we have times derivative of that. Or if we use the parentheses to the 5th, derivative of that is 5 times the parentheses, and then derivative of the parentheses square. Doesn't matter what we put inside the parentheses, as long as it is the function of x. Now if I want to, I can put a function of x in it. It could be even y of x. Then I have, oh sorry, forgot the 4 here. Then we have 5 y of x, and then y of x here. And the derivative of that is just y prime of x. and that go one step further. Now let's just, if we just have y, then that would be 5 parentheses to the fourth parentheses prime. Then we're going to put y in it, so that gives us 5y to the fourth y prime. This is only if y is a function of x. And in that case, that is implicit differentiation. Right. How did that apply to our problem here? So, calculate dy over dx, meaning derivative of y with respect to x. So I'm going to circle that. When we see this, we mean y is a function of x. X is the independent variable, y is the dependent variable. Or when I see that, I see y is a function of x, and that's what I start with. Assume y is a function of x. After that, we take derivative implicitly with respect to x. Or we just take derivative is equivalent to saying differentiate. So, or differentiate meaning take derivative. Differentiate x squared plus y squared equal to 25 with respect to x. And differentiate meaning take derivative or find derivative of something. Right. Now the reason I write different colors. Now let's just go back. X squared plus y squared equal to 25. Now, since y is a function of x, that's why it is important. So y is a function of x. So put the parentheses around it, because the y itself contains an x in it. So we treat that as a variable that contains x in it, a function of x. So we take derivative of x squared give us 2x, right? And derivative of the parentheses, just like last time, doesn't matter what it is inside the parentheses, we will have something square. It's going to be 2 times, I just want to write like this, 2 times the parentheses, and then the parentheses prime. It doesn't matter what it is inside that, as long as it is a function of x, it works. Derivative of 25, it is a constant, so that equal to 0. Right. So x squared plus y squared equal to 25. We differentiate with respect to x. With respect to x, give us this. Now inside that is y prime. So we have 2x plus 2y, and then y prime. Now if we just need to solve for y prime, we subtract 2x on the other side, 2y, write y prime here, equal to negative 2x, and finally move the divide by 2y on both sides. We have y prime equal to negative 2x over 2y, cancel the 2, negative x over y. So that is derivative. And derivative implicitly, it may contain y in it, which is perfectly fine, because we don't need to solve for y as a function of x. Alright, next, find the slope of the unit circle. It's not the unit circle. of this circle. Of the circle x squared plus y squared equal to 25. So we have the same equation. I'll change that in the notes so don't have to worry about that. At 3 and 4. So at 3 and 4, I'm going to just put 3 in for x, 4 in for y. That's it, right? 3 in for x, 4 in for y. So that's all we have. And at 3 and negative 4, once again derivative, put 3 in for x and negative 4 for y. That gives us 3 over 4. Right. Now, next, show that this is the same result if we found the derivative explicitly. Alright. Now, in that case, we have to solve for x. So this way we differentiate with respect to x first. Now, here we do that explicitly, meaning y equal to something. So we solve for y first. Involving subtract x squared on both sides. And take the square root on both sides. Every time we take the square root on both sides, forget there's a plus or minus. So we have y equal to plus or minus square root of 25 minus x squared. Right now we take the derivative of this. Now this is just a chain rule. Derivative of this. We can write this as plus or minus square root of 25. Square root, I want to rewrite that. minus x squared, we write that as the power 1/2. Right, now we take the derivative. So y prime will be equal to, now derivative, and this is a chain rule, something to the 1/2 power. I'm just going to put the plus or minus in front of it. Something to the 1/2, meaning let's put the parentheses around it. Then we have 1/2, something to the negative 1/2, and derivative of that. Right, now we have 25 minus x squared in front of it. I mean inside of the parentheses. Right, that gives us plus or minus 1/2. 25 minus x squared to the negative 1/2. Derivative of 25, that constant, derivative is 0. Derivative of negative x squared, that will be negative 2x. Okay, take derivative. And since this is to the first power, and this is 1/2 also to the first power, I multiply together. And this is a plus or minus multiplied by a minus here. So it's still plus or minus, right? But that will be, let's say, minus and plus 1/2 times 2x. Right, 1/2 times 2, so I should have just negative, positive x, 25 minus x squared to negative 1/2. And finally, at x equal to 3, derivative equal to, I'm going to put 3 in it. I mean 3 is torn to x. and then we have x times 25 minus x squared to the negative 1/2. That gives us 3/4, and will be minus plus 3/4. Of course, the derivative we did earlier, we have negative 3/4 or 3/4. So this will be the same. By the way, it is indeed the same if we rewrite a few more steps with, because I run out of space, I did not write it, but it should be like this. So if x 25 minus x squared to the negative 1/2, right? Now, of course, plus or minus. The negative power, I can move it down to the denominator. So I plus or minus x over 25 minus x squared to negative 1/2. Actually, just put the plus or minus at the bottom. Still fine, right? Yeah. When we move to the bottom, the power becomes positive. That's why I forgot. Alright, so x equal to plus or minus 1/2 power is square root 25 minus x squared. Right? So plus or minus, just move to the bottom. It's fine. Negative 1/2 move to the bottom, power becomes 1/2. And finally, we did have y equal to plus or minus of 25 minus x squared to the 1/2. Or this here is y, right? Or this is y. I mean, including the plus or minus is y. Yeah, y including the plus or minus. So that's why I moved that to the bottom. And we have plus or minus square root of 25 minus x squared. So the answer is x over y. Right? And then you say, nope, it's not. This is negative x. So why is that? Okay. Now, the problem is, in this case, y, when we write like that, y could be negative. But if we write like that, it cannot be negative. So in that case, have to, this is minus and a plus, if we have to be careful with that. If we want to be careful with that, that is a minus and a plus, meaning that it is plus or minus if we have an extra negative. Right, minus plus, minus divided by plus or minus. Right. In that case, this is y, and we have negative x over y. So, as you see, the plus or minus, that's rather confusing. Sometimes we have to solve for y, and we substitute back. So it is not very convenient if we do that. So that's why implicit differentiation is very nice. But in the sense that we don't need to know what is y equal to. As long as we can find the values. Here we know the values, so it's fine. Of course, when we have the relation, we can solve for y. But the point is, if we don't need to. So, to solve anything which confusing like this, it's best just use implicit differentiation, so we don't have to worry about what y is. Right. Now, I'll find y over dx for that one. Now, once again, dy over dx, that means y is a function of x. And then we will differentiate with respect to x, 3x squared plus 1 now, if y is a function of x, I'm going to put the parentheses around it. to let me know that y is a function of x. And so I need to apply the chain rule for it. Right, now differentiate with respect to x. Derivative of 3x squared with respect to x is 6x. Derivative of 1, that constant is going to be 0. Now what is derivative of 5x squared, 5x cubed times y squared? Right. Notice that it's a bit more complicated here. 5x cubed, we have x in 5x cubed, right? So this is a function of x. And y squared is a function of x as well. So what we have here is the product rule. Since we have two functions of x multiplied together, it has to be a product rule, right? So u is 5x cubed, v is y squared, where y is a function of x. Derivative of u is 15x squared. Derivative of v, this is the function of x, so use the chain rule. It will be 2 parentheses, derivative of the parentheses. It just happened to be y in it, so just do y prime. So every time we have y, just put the parentheses around it, signal that this is the function of x. Right. So u prime v, u prime v u prime v plus u v prime. Right, multiply them out. That 15x squared y squared, 5 and 2, that 10 x cubed y, and then y prime. And of course we solve for y prime. Try to get y prime by itself. This is the plus, so I will take the 15x squared minus 15x squared y squared to the other side. And then divide that down the denominator. So I will have, of course, since all of them have x, we can cancel out an x. We also can cancel 2, but we can do that later. So we solve for y prime. We're going to take that, divide by 10x cubed y. Sorry, we cannot cancel 2 because of the 15, but we definitely can cancel 1x, right? So factor out an x, just 1x. And then we cancel 1x, we have 6 minus 15xy. Over 10 x cubed. X cubed cancel 1x, just x squared. Y. Right. So assume y is a function of x because the problem asking us to find the derivative of y with respect to x. So definitely y is a function of x. So put the parentheses around that, signal that there's x inside the y. We just don't know what it is. Right, take derivative, that's 6x. Derivative of one constant, that will be 0. So this is the product rule in trying to solve for y prime. Subtract this to the other side and then divide by that. Yeah, so just that. So the answer usually have y in it, but that's not important. Right, next, find equation of a tangent line to the curve x squared plus xy minus y cubed equal to 7 at the point 3 and 2. So equation of a tangent line, equation of the tangent line, in this case a is 2, a is 3, at the point 3 and 2. So a is 3, and the values of the function in fact, in this case, this is not even a function. This failed the vertical line test. So f of a here, sometimes we just say this is just y, but for now, just leave it like that. The focus here is, of course, like I said, we may or may not have the function, so that's questionable, but it's fine, it's okay, just leave it like that. The point here is, of course, is we find the derivative of the tangent line here. So this is dy over dx at x equal to a. So derivative when x equal to a, which is x equal to 3 here, that is derivative of the tangent line. So pretty much we find the derivative. So first we assume y is a function of x. Next, we differentiate and we write the equation x squared plus xy minus y cubed equals 7 with respect to x. And since y is a function of x, I put the parentheses around that to signal that we have x inside the y, and so we have to use the chain rule for it. Right, now derivative of x squared, that is 2x. That's the first one. That derivative. Of course, you don't need to write on this arrow. I just do the arrow, just signal what that equate to. The derivative of x squared gives us 2x. Now, the x times y. Notice that x by itself has x in it, obviously, and y is a function of x. That's what we let equal to. So here we actually have a product rule. So u equal to x and v is equal to y. And derivative of x, of course, is 1. So what is derivative of y? Now, if you put the parentheses around it, derivative of v, derivative of a parentheses to the first power, derivative of x to the first power is just a constant, just 1, right? So in that case, derivative of the parentheses is 1 times derivative of the parentheses. Yeah, derivative of x is 1. Derivative of the parentheses is 1 also. But derivative of that or we just say it, yeah, derivative both sides, so just y prime. Right, so I have 2x be the first term. Next, this is going to be a product rule. I put the parentheses just so that I know it is the product rule inside. U prime v plus u v prime v prime. So that inside is this, and derivative of the y cube, derivative of y cube. Again, there is the parentheses, so we have 3 times the parentheses where that derivative of something cube, and then derivative of that. And the right hand side, derivative of 7 is a constant, derivative of constant is 0. So as you see, what we have here is x squared is 2x, x times y derivative is the product rule, y cube, I put y in here, it's going to be y prime, I mean 3y squared times y prime. So to rewrite this, I have 2x plus y plus x y prime minus 3 y squared y prime equal to 0. Since we solve for y prime here, I will just highlight that. We're going to solve for y prime. These two terms doesn't have y prime in it. I move those two to the other side. And both of them have y prime, so I can factor out the y prime. So factor out y prime. You have x minus 3y squared equal to the 2x and y move to the other side, becomes negative. And then I can divide that to the other side. Right. So that gives us the derivative. This is y prime. By the way, like I said, the notation for whenever possible, I just write y prime. But of course, if we don't want to, we can use dy over dx instead of y prime. But whenever possible, I prefer to write y prime, because in this problem we know y is a function of x, so y is the dependent variable, x is independent variable, so it's very clear to the context. I don't need to write dy over dx. Right. And then at 3 and 2, when we substitute 3 in for x and 2 in for y, we have the slope. So at 3 and 2, meaning that x is 3 and y is 2. When you do that, substitute 3 in for x and 2 in for y, we actually have the slope of the tangent line. So negative 2, x is 3, y is 2, over x is 3 minus 3, y is 2 square. So do that, you have negative 8 on the top. At the bottom, 3 minus 12, so that minus 9. So that gives us a over 9. So we have the slope equal to 8 over 9. And finally, put everything in the equation of the tangent line. Y minus, yeah, around f of a might be a problem because this is not a function. They may not be a function, but just we don't have a better notation than that. We know the values is y values is equal to 2 though, so y minus 2 equal to 8 over 9 x minus 3. Multiply them out, y minus 2 equal to 8 over 9x. Multiply them out, 3 and 9 cancel out, minus 8 over 3, and plus 2 on both sides, so y equal to 8 over 9x. Plus 2 on both sides, negative 8 over 3, plus 2 is minus 2 over 3. And that's what we have. Right, I won't be able to put this in the calculator because I cannot graph this function because it is not a function. It failed the vertical line test here. So remember, if I put anything in the calculator, it has to be y equal to something so I can graph it. I cannot do that here because it is not a function. And that's the advantage of implicit differentiation. That we don't need to know if y, we don't have to solve for y equal to something x. As long as we know the y values, that's good enough. The answer might have y in it, but that's perfectly fine. Right. So, we see that if we assume y is a function of x, we take derivative both sides and try to solve for y prime. By the way, since y is a function of x, I put a parenthesis around it to signal that it has x in it. So in that case, we will treat that as a function of x, and two functions of x multiplied together. That is the product rule. Right. So that's why I put the parentheses, just to signal that. More examples. Now, here we know that we can use implicit differentiation because in that case we don't have to solve for y. That's an advantage, big advantage. But that's not the only advantage we have. Even better, if we look at this problem, you'll see that 2x plus y to the 1/3 equal to y. Now if we have to take derivative with the 1/3 power, that of course the product rule, the chain rule still work, but that's complicated. So why don't we cube both sides? Make things a lot more easy to evaluate. So 2x plus y to the 1/3 equal to y. So what if we cube both sides? Now, so why do we do that? Just bear with me. 2 to the cube, to the third power is 8. 1/3 power to the third power. So we have x plus y to the 1/3 and then cube. A power to another power, we will multiply the exponents, multiply the powers. 1/3 times 3 is 1. So we just have 3, 8, x plus y, and then y cubed. Of course, we can multiply it out the x. Equal to y cubed. Now, if I ask you, would you prefer to take derivative of that or take derivative of this? And you say definitely this, right? Because that 1/3 power and then the fraction of power rule take down the 1/3 and then the power. So that's complicated. Still work if you want to take derivative here. So the big note that we hear is that sometimes it is a lot easier to take derivative implicitly because we can manipulate the equation. We cannot manipulate the function. When we say y equal to 5x plus 1, for example, then that is y equal to 5x plus y. We cannot multiply both sides by 2. In that case, this is no longer explicit function. The explicit function has to be y equal to something. And we cannot change anything on the left hand side. Because of that, we cannot change anything on the right hand side either. And that is the big disadvantage. Whereas here, we have the equation perfectly fine. we can do the same thing on both sides of the equation. We don't have to keep the y on one side, right? So in that case, we will take the differentiate of this with respect to x instead. So differentiate that with respect to x. Of course, before that we assume y is a function of x. That's of course the normal thing. So we put the parentheses around it. Right, derivative. Ax derivative of 8x is 8. Derivative of 8 times the parentheses. Derivative of 8 times the parentheses is just the parentheses. It's just 8 times, right? Derivative of ax is 8. Derivative of 8 with a smiley face is just 8 if the variable is the smiley face. But in this case, that's the parentheses, so we have derivative is 8 times derivative of the parentheses. Next, the parentheses cube. Doesn't matter what inside the parentheses, something cube, it's going to be 3 times something square, and then derivative of the parentheses just happen to be y in it. So we write this, we have 8 plus a y prime equal to 3y squared and then y prime. Now, of course, later on we said if we have, that's just y prime. By the way, yeah, I will talk about that in a minute. But here we solve for y prime. Right. So let's move everything to one side. So I move this to this side. And move the a to the other side. So do that, and we have 8y prime subtract 3y squared y prime equal to, so move that to the other side, move the negative a to the other side. Factor out the y prime. Have 8 minus 3y squared inside. And finally solve for y prime. Equal to negative 8 minus 3y squared. And finally, they want to find the slope at 4 and 4. So 4 is for x, 4 is for y. So this equal to negative 8. 8 minus 3, y is equal to 4 square. 4 square is 16 times 3. So we have 8 minus 48. So minus 8 over minus 40, which is 1/5. And of course, the answer is 1/5 like we have here, which is good. Right, of course, that's one way to do it. The other way is, since we solve for y prime, and that when x equal to 4 and y equal to 4, so when we have this equation, if we just zero in y prime, just trying to solve for y prime, I will put y in directly here, because I don't need to do anything else, because we know x and y is 4 and 4 already, so we just need to do that. So that gives us 8 plus ay prime equal to 48 y prime. Move this to the other side, give us 40 y prime equal to 8. So y prime is equal to 8 over 40, which is 1/5. So my point is you can just put the number directly into the equation and solve for y prime. In that case we have numbers, but doing this way we have the general derivative that have x and y in it. So in that case whatever the numbers in we can put in later. Right. So just write a little note here for implicit differentiation. We can and should manipulate the equation so we can have something easier to differentiate. Simplify the equation so the differentiation is easier to carry out. Before differentiating. Yeah, so we should do that. Like this is an example. We can see that a bit advantage. Yeah. Right. Once again, we cannot put that in the calculator because this is not a function. Right. Next. Find y prime for the following function. Right. So y prime meaning that y is a function of x and we find derivative with respect to x. So that's normal here. However, let me ask you this. If you have to take derivative of this one, the left hand side, that is the quotient rule because we have a quotient obviously. And that's look like a lot of work and I don't want to deal with that. So in that case, we go back to this. We said if we can simplify the problem, we should. Sorry, I make a mistake in the calculation, so I have to stop the video, cut that out, and then do the problem again. Right. So just like what we did earlier, we should simplify the equation, differentiate. So in that case, I will cross multiply a fraction, cross multiply minus 5y to the 4th equal square 4 ax minus 2y. Right. And because if we have to differentiate, that one is a lot easier than that one, which involve the quotient rule. Right. So as we start with, assume y is a function of x. And then we differentiate y is a function of x with respect to x. So we have 3x squared, derivative of 3x squared, 6x. Derivative of 5 to the parentheses to the 4th power. So 5, put something to the 4th power. Doesn't matter what inside. Take the 4th down, make it 20 cube and then derivative of the parentheses. Right, and of course inside is y. Derivative of ax is 8. Derivative of 2y is 2, and then y prime. Right, multiply them out. 6x minus 20y cubed, and then since we solve for y prime, try to make it look a little bit different. We solve for y prime. Right. Now solve for y prime. Let's move everything on one side. Let's move the 2y prime to the other side. Make it positive. So let's just say add 2y prime to that side and subtract 6x to the other side. That equals 8 minus 6x. Factor out the y prime. By the way, we can divide everything by 2 if we want to. Yeah, so y prime, factor out, we have 2 minus 20y cubed, and finally divide by the parentheses. So y prime equal to 8 minus 6x over 2 minus 20y cubed. Of course, like I said, we can simplify, divide everything by 2. 4 minus 3x, 1 minus 10x, 10y cubed. Right, so just like the previous problem, if we can simplify the problem, do that. That helps us. Derivative of this is a lot easier than use the quotient rule. Right, so that's what we have. Next, find derivative of y here. This one we just have to go ahead and do that because it looks like simplifying already. So once again, assume y is a function of x, because in this case we'll find y prime still. Of course, we can also say sometimes if we want to, we can take x as a function of y and we do the same thing. But in that case, we have dx over dy instead. And now we differentiate this with respect to x. I'm going to put the parentheses around that too. Once again, right, differentiate this with respect to x. Right, now cosine of y squared. Notice that this is not cosine. This is not cosine y squared like that. This is cosine of y squared. So in that case, I need to put an extra parenthesis around it. Let's use a bracket here. Right. Cosine of something is negative sine of the bracket. And then derivative of the bracket. Doesn't matter what inside. Just happen to be y squared inside. derivative of x is 1. Derivative of 2 times y squared is going to be 2 times parentheses prime. Right, like that's negative sine y squared, we cannot really do anything with it. But derivative of this we certainly can. So that gives us 2 parentheses prime plus 1 equal to 2y prime. Right, now the 2y here, if I write that in front, I don't need to write the parentheses here. So this will be negative 2y sine of y squared, and then the y prime plus 1 equal to 2y y prime. Right, move everything on one side and solve for y prime. The rest should be simple. So I will move this to the other side though, because in that case both of them will be positive. I have 1 on the right hand side, 2y sine y squared y prime plus 2y y prime factor y prime inside I have 2y sine y squared plus 2y. In fact, I can just factor out 2y if I want to, but we don't need to. We just need to factor out y prime because that's what we solve for. Right, and then divide this on the other side. So y prime equal to 1 divided by 2y sine y squared plus 2y. Right. So that's what we have on that one. Right. Now what happens if we have to use the second derivative? Right. So that go to the next example. Right. Now find second derivative for this equation. Once again, y is a function of x when we see that. So first we assume y is a function of x. And then we differentiate with respect to x. Right, derivative of x squared, that 2x. Y is a function of x. So that gives us 2 times the parentheses prime. Derivative of 1, that constant, is going to be 0. Right, so in that case, let's simplify 2x plus 2y y prime equal to 0. Solve for y prime. Move the 2x to the other side. and divide by 2y. Cancel out the 2. So the first derivative we have, of course we already did this, y prime, or if we want to, dy over dx is equal to negative x over y. So that is the first derivative. The question wants the second derivative, meaning that we have to take derivative of this once again. So what we do is differentiate this with respect to x one more time. Derivative of derivative is the second derivative. So differentiate y, I'm going to write what we differentiate, y prime equal to negative x over y with respect to x. So we do that 2 times, we have the second derivative. Right, so you can put the parentheses around it if we want to. Y is a function of x once again. Now, I have to be a little bit careful on the left hand side though. What we have here is derivative y. Now, what if we take derivative of that one more time? So in that case, we just have derivative of the bracket to the first power, right? So that means we just have that. Or just derivative of the bracket itself is just 1 times just that, because we don't do anything, right? So pretty much we're going to have derivative of it. So when we take derivative, it's going to be just, still the parentheses here, just going to take derivative of that one more time. We'll make it second derivative. Right? Yeah, so y prime is that, so that's just second derivative. So in that case we have second derivative. Now, what we have on the left hand side is a quotient rule. Right. So u is equal to negative x, v is equal to y, derivative is equal to negative 1, derivative of that. We've done a bunch of this already, so that's just y prime. So put everything in the product, and in the quotient rule, I mean u prime v minus u v prime. Over v squared. So that gives us negative y, negative, that plus x, y prime over y squared. Right. It's not that bad, right? The first derivative, if we take derivative one more time, that gives us second derivative. That's easy. Right, now, the y prime here, we did earlier, they said negative x times y, right? So I substitute that back in there. So how to simplify this? Before we do anything, let's just multiply this. We have negative y, x times x. So that gives us x squared over y. Right. Now to simplify this, I will multiply top and bottom by y, because in that case it will cancel with this y. So do that, we will have negative y squared, y and y cancel out, negative x squared over y cubed. So that is the answer, which is nice, but we can make it even better if we factor out the minus. Inside, if we pull out the minus, that's just x squared plus y squared over y cubed. And what is x squared plus y squared? It is equal to 1. So the answer is negative 1 over y cubed. So then that will be very nice. Once again, this one we asked to find second derivative. So we take the derivative first, and then we take the derivative one more time. The second time we have to use the quotient rule. And when we simplify, we have x squared plus y squared, which is 1. So we substitute back in. That's what we have. Right. Next, find the slope of the tangent line to the graph at x equal to 1. So this is potentially there may be more than 1. So first let's say when x equal to 1, what is y equal to? Right. At x equal to 1, substitute in this equation, y squared plus 3 times 1 equal to 4. So y squared equal to 4 minus 3, which is 1. Take the square root on both sides. Be careful when we do that. Plus or minus. So we have y equal to plus or minus square root of 1, or just plus or minus 1. So in this case we have 2 points. Xy equal to, when x equal to 1, y could be 1, or when x equal to 1, y could be negative 1. So we have 2 points. Right. After that, we find the slope. Just find the slope. Don't need to find the equation of a tangent line. So the slope, of course, is the derivative. So same thing. Assume y is a function of x. Differentiate that with respect to x. Y squared, derivative of y squared is 2 times the parentheses, because y is a function of x. Derivative of 3x is 3. Derivative of 4, that constant, 0. So we have 2y, y prime, plus 3 equal to 0. And so for y prime, y prime equal to negative 3. So we have y prime equal to negative 3 over 2y. Right. We have 2 points here to just substitute in. At 1 and 1, the slope equal to negative 3 times 2 times 1, so negative 3 half, and at 1 and negative 1, y prime equal to negative 3, 2 times negative 1, so that gives us 3 half. Right. So because we have 2 points, find 2 slope, even though there's only one value for x, that 2 corresponding value for y, so that's definitely not a function. Y is not a function in terms of x. Right. So that's what we have. Right. So usually in the book, I'm not sure how the book writes it, but I prefer to just write y. If here I write y is a function of x like this, and when I take derivative, I become 2y of x. Yeah, I could write like that too, but with the x here, that could be kind of confusing here. So in that case, I just ignore the x. Assume y is a function of x and treat that as a function of x, so I put the parentheses around it, so it doesn't matter what inside of it, it's still just the chain rule. Right? Yeah. So, and the key here is implicit differentiation is we don't need to solve for y. And if we have the equation that complicated, we can always simplify that. At the last step, try to get y prime by itself. Right, so that's all we have. So I stop section 3.8 here. See you in another video in Calculus 1. As always, thank you for watching.